Welcome to Chibuzor Mathphysics. In today's video, we are going to be dealing with nuclear reactions, and this is one of those units you need to do in nuclear physics. And we are dealing with nuclear reaction. So let's take a question. You have to calculate the Q value of the following nuclear reaction. So let us have the reaction. We are going to have helium. The reaction would be helium with mass number 4 and atomic number of helium, we know it is 2, plus nitrogen with mass number 14, and it has the atomic number is 7, and this should give us oxygen 17 as a mass number, and atomic number is 8, plus hydrogen is 1, the mass number is 1. Then usually we add the Q plus Q because we are looking for Q. So how do you calculate the Q value of this reaction? Before we dive into calculation, I would like to explain what is Q value in physics or even in chemistry. When we talk about the Q value in physics and chemistry, the Q value for a reaction is nothing but the amount of energy absorbed or released during the nuclear reaction. So it is a kind of nuclear weapon. So if there is a reaction that is going to happen in this following reaction, you see this is helium plus nitrogen, and then we have oxygen and hydrogen. So the amount of energy that is going to be absorbed or released during this reaction is what we refer to as a nuclear reaction. Of course, when you are given this kind of question, you will be expected to know the mass number of helium, the mass number of nitrogen, the mass number of oxygen, and the mass number of hydrogen. So usually it is constant and it will be provided to you. So let us have the mass number. What is the mass number of hydrogen? In this case, let's take 4 as a mass number of hydrogen. Let's take 4.00603 4.00603, and let's take the mass number of nitrogen. Mass number of nitrogen in this case, let's take that to be 14.003,074, and the mass number of oxygen, let's take that to be 16.999,999,133. These numbers are constant. And the mass number of hydrogen, in this case, this is helium. The mass number of hydrogen, you will have it to be 1.006024. So all these numbers will be given as a constant. This will be constant, all these numbers. So you need to have this number for you to calculate the Q value of this reaction. So now let us dive into calculation. To calculate the Q value, Q will be given by helium. We know that we have helium, which is 4.2 as the mass and the atomic number, plus nitrogen. Nitrogen in this case is having 14 and 7. 14 is the mass number, and the atomic number is of course the atomic number is 7. What we refer to as the mass number actually is the number of protons plus neutrons. That is what we refer to as the mass number. It is simply the number of protons. Let's have that down. This is the number of protons. Protons is represented with letter Z. This is the number of protons plus the number of neutrons plus neutrons. So let's have that down so that you're able to follow what we are doing. This is exactly what we mean by the mass number. And of course, the atomic number in this case is the number of protons. Atomic number is simply the number of protons. Number of protons. Of course, you say that the number of protons, this is Z. But in this case, this one is the number of protons plus neutrons. But here, it is simply the number of protons. So, this is how to calculate the Q value. This is equals to helium plus nitrogen. And then we are going to minus oxygen, which is given as 17 as the mass number, 8 as atomic number, and we add hydrogen, 1. So this is exactly what we need to do. So the number, the mass of hydrogen, the mass of helium is given. So it is simply 4.00. Let's have it down. Plus the mass number of nitrogen, which is 14.003,074. This represents whatever we have here, helium plus nitrogen. So we are simply taking the mass number. So now you minus the mass number of oxygen, which is given at 16.999,133 plus the mass number of hydrogen, which is 1.00, and then 6024. So this is what we have. Add this up and plug this into your calculator. You will simply get 5.2 times 10 raised to power negative 4. But we know that 1 electron volt is equal to 931.5 MeV, that is mega electron volt. So multiply whatever you have here with 931.5 MeV, so that our final answer will become positive 48438 mega electron volt. And this is our Q value. Now the solution here is positive, so the reaction of this kind is called exogenetic, because you see it is positive. When it is positive, it tells you what kind of reaction that it is likely to happen. So there are some of this reaction that can show you things like electron capture and other stuff like that. So this is how you calculate the Q value of a nuclear reaction. And like I said earlier, when you are referred to explain what you meant by nuclear reaction, it is simply the value for reaction. It is the amount of energy absorbed or released during a nuclear reaction. Of course, the reaction quotient can be denoted as Q. That is a different thing because it measures the relative amount of product and reactant present during a reaction at a particular point in time. That is, if you are asked to explain what exactly is the meaning of Q. Q measures the relative amount of product and reactant present during a reaction at a particular point in time. But in nuclear physics, Q reaction or Q value is simply the amount of energy absorbed or released during the nuclear reaction. We will continue the next video with another question that involves calculating and demonstrating what exactly is Q value of a nuclear reaction. See you in our next video. My name is Augustine Galagash.